something.
Absolutely.
Yeah, let me get rid of these pictures because it's covering up. How do I get? Hmm. How do I get rid of you folks on the right-hand side?
It's all right. We can see your screen there. Shouldn't be a problem.
Well, okay, but I can't see it all. But I think I know what's there. Okay, I'm going to talk about an antenna that I put up a couple of years ago. Covers all bands from 630 meters to 10 meters, 474 kilohertz to 28 megahertz. Covers all those bands. And this came, oh dear, what's going on here? Okay, this came about because over the years I've been very fortunate to have towers and beams, initially in the east, then Calgary, and when I moved here, Richmond, and then Victoria. But unfortunately, with the passing of years and my knees starting to go, I realized I couldn't climb the tower anymore. So I had to come down, and then I got to do something else. So, like any good project, you've got to define what you want. And what I wanted was coverage of all bands from 630 meters to 10 meters. My prime interest is worldwide CW contesting on, on all bands 160 through 10 meters, which suggests a vertical antenna for 160 and 80 and a horizontal for 40 through 10. And I'm not one for these 80-meter nets or 40-meter nets, so I don't need an NVIS type antenna. And I also wanted 630 meters. One of the things when you're looking at antennas is it's nice to know where you want the radiation and what sort of radiation pattern you're really looking for. So a great circle map centered on Victoria. That showed me that for Europe, I needed something to the northeast, VKZL, opposite direction, and Asia and South America, kind of like 40, 90 degrees to those directions. Now, ah, how do I get to the next slide? Up the top here. Next.
Spacebar should do it.
Okay, yeah. Okay, well, let's look at my lot and see what I can do. You can see on the right-hand side an arrow pointing north, and the lot from the back of the house to the far property line is about 100 feet. Lot's about 55 feet wide and many trees.
3451.
Sorry?
Just make certain there's three houses there. It's one in the middle. Seems obvious, but there it is.
Yeah, that's the one in the middle. Yeah. As you can see, there's lots of trees either side and in the front yard as well, and a big clear space at the back. And I know a lot of people are very fond of these end-fed half waves, but they don't really turn me on. I like center-fed antennas, which to me are kind of more predictable. Okay, so somebody said spacebar right. So yes, so I got lots of tall trees, as you can guess from the picture. I've also got a 30-foot lightweight tower which supports an over-the-air antenna. Like to watch PBS direct from Bellingham, and some of the other US stations on the islands. I've also got a limbless tree which can be used to support one end of an antenna. And the limbless tree was one of three that the city gave me to cut down. But I didn't really want to cut it down. I just wanted to shave all the branches off it. And the city said, well, once you've got permission to cut it down, you can do whatever you want with it. Turn it into a bear, big fish, an orca, whatever you want. So I had all the branches cut off, and it's now a nice vertical, probably about 35, maybe 40 feet high. And I got a big pulley at the top with ropes. So that's my limbless tree. Anyway, I decided I would put up two antennas, the big one primarily for Europe and VK, and the other one for Asia and South America. And the big antenna number one,
Number 1.
what's going on here?
What's going on here?
So turn off your,
Now,
everybody go,
everybody
go mute, please.
go mute, please.
Sorry, somebody talking to me?
Somebody talk.
Feedback echo.
So both Dons, could you go mute, please?
Yeah, I gotta find. I've lost my. I lost my Zoom here. What the hell? Let me try and get out of here, and I'll come back.
Okay. Well, I will carry on. I guess I'm still being heard.
Yep.
Okay. So anyway, I'm going to have two antennas. Antenna number one, what I'll call the prime antenna. That's the one that's going to go to Europe and Asia VK. That's going to be a doublet, and I'm going to use it as a top-loaded vertical for the low bands. And the second antenna, which will be for Asia, primarily Japan and South America, that's going to be 15 and 20 meter parallel dipoles. So what is a doublet? It's actually nothing more than a horizontal wire which is fed at the center, and you can either feed it with a ladder line type arrangement or this window line, which you can see on the left, or ladder. Well, I tend to refer to the window line as ladder line. It's this 450 ohm type stuff. The really beautiful thing about the doublet is it does not have to be resonant on any band, because using it with a balance line or window line and a good ATU, the losses are going to be absolutely minimal. If you're going to use coax and it was not resonant, then the losses would be horrendous. But feeding it with open wire, balance line, the losses are negligible. So you can use it as a horizontal radiator, which I do on the high frequency bands, or you can join the bottom ends together and just use it as a top-loaded vertical, which I do on the low frequency bands. Disadvantages? Well, you've got to have a wide-ranging matching network. That's going to be required. And installation of the ladder line, it's not as convenient as coax, that's for sure. Might have had another note here. Let's have a look. Oh, yes, the other note I should have put on here is if you're using this 450 ohm ladder line, which I do, then its characteristic impedance changes when it gets wet, and then you have to readjust the antenna matching unit. No big deal, but that is a bit of a downside. In fact, if I was going to do it again, and maybe if I was 15 years younger, I'd make myself up some true balance line, maybe 5 or 6 inch spacing with suitable non-conductive spacings between them, which of course is what amateurs used to do in the days before World War II, and I guess a few years immediately after. And then coax, of course, came along. So let's look at the big antenna, number one. This is kind of a schematic or sketch of how it's implemented. The top length, it's 54 feet from one end to the other. And that length was determined by using EasyNet, one of these antenna software packages, which is no cost. You can get it online. And I just kept adjusting the length until I had the lobes at 90 degrees coming broadside for what I wanted, for 20 meters and 15 meters and 40 meters. It's not really high enough for 40 meters for good directivity, but it does work well. And I will say there's many occasions in a contest, if 40 meters is open to Europe, then I will certainly work quite a few Europeans. And similarly, Australia, New Zealand in the mornings. So it's 54 feet long. It's about 55 feet above the ground, suspended between a couple of trees. And that 450 ohm line that you see going down goes to a double pole, double throw relay, which is on a post about 6 feet above the ground. And that double pole, double throw relay, if I'm using the doublet as a horizontal antenna, then the 450 ohm down lead gets connected to another section of 450 ohm, which goes to the radio room, where I've got a matching unit and then, of course, the radio. If I'm using it as a top-loaded vertical, then this double pole, double throw relay disconnects the line that goes to the radio room, connects the two conductors together, and then to a vertical piece of aluminum tubing, probably about 5 feet long, goes down to a wooden box, which you'll see a photograph of very soon, or a picture. Oh yeah, a photograph. Then I got relays in there, plus matching units for 630, 160 and 80 meters. And then I have one coax for 630 and another one for 160 and 80, and some 6-conductor cable to control all of the relays. And then, of course, lots of radials for using it as a vertical antenna. Not as many radials as I would like. This is looking... Somebody say something?
Yeah, Brian,
Yes, sir.
could you skipped over one of your maps pretty quickly.
Did I? Oh.
Could you go previous a few times and show us where those antennas are again?
Yeah.
Please.
This one?
That's the one right there. Yeah.
Okay, this is the big one that I just described. And these are the parallel dipoles for 20 and 15, which I'll come to a bit later.
Okay.
Okay, let me go back to where I was. Okay, this is looking from the back of the house towards the far end of the lot. And this is a post with the relay on top that switches the balance line. You might just see it coming down here. A more balanced line going to the radio room. I'll show you some closer pictures a bit later. But at any rate, you might be able to see this aluminum rod. So when I'm using it all as a vertical, it goes into this box where I got the matching units for the LF bands. So here we are, closer view of what I've got there. 450 ohm comes down into this relay box. There's about 6 inches of plastic plumbing here, which acts as a support or strain relief, if you like, for the 450 ohm line, because not surprisingly, it flaps around a lot in the wind. And then I've got 450 ohm going to the radio room. And this wire you see here, this is actually the 6-conductor cable that controls all the relays. I think in the previous one I showed it as being buried, but the wife is a great gardener, and a few months ago when things stopped working, I realized that my darling wife had sliced through the cable that switches all the relays. I can see Rick chuckling away there. So I had to find out where it was broken, and I thought, bugger this, I'm going to run it overhead. So that's what I did. One interesting thing was when I moved that cable from being buried in the ground to where it is now, is that the matching on 630 meters changed. I guess it's close enough that doesn't take much to change the resonance of the 630 meter antenna, which of course is electrically very short, has a very high Q, and doesn't take much to off-tune it. Anyway, this is the relay that switches it between it's double pole, double throw, takes the 450 ohm line coming in here and off here if it goes to the radio room, and here switches it to the aluminum rod that goes down to the LF matching units. Now on the low bands, particularly 630 meters, you get some very high voltages developed in these relays. And over the years, I've gone through several of them. So this is my plea. If anybody has relays that look something like this, it's probably about 2 inches, maybe 3 inches. You'll notice there's lots of spacing between the moving arms and the armature and the rest of it. Relatively wide spacing, a couple of millimeters. I'd be happy to unload them off you because I've gone through quite a few over the years. And this one is in a clear plastic box. There's space here at the bottom for any moisture to clear out. I did have one that was in a plastic plumbing box, which I'll show you towards the end, but you couldn't really see what was going on inside. At least here, if I start to see any arcing or carbon tracking, I'll know to start taking it out and cleaning it. And it seems up here I've got some little critter, looks like it's making its home. But it won't be long before a couple of 1,000 volts will put him in his place.
Yeah.
So moving on, that aluminum rod that you see, it's coming down here, and in this picture I've got it through an RF ammeter, which most of the time is not there, but it's very useful when I'm fiddling around with 630 meters to see what the antenna current is. Otherwise, it's removed, and I have a jumper across a couple of ceramic insulators, and you can just see a bit of wire here. Goes to a ceramic feed through in this box. And then there's another of those double pole, double throw relays. So when I'm using it as a vertical, I can switch the end of the feeder to either a variometer, which I use for 630 meters. And the variometer is nothing more than a big inductor with another inductor in series in between, which you can then move to vary the inductance. So typically what I've done is at the bottom here, where there's a coax connector, takes the coax to the radio room for 630 meters. I put my nano VNA there, and then I can just adjust this. This is a very fine adjustment, and I can see on the nano VNA when I got it resonant on 630 meters. I have to say that nano VNA for a low-cost device is just a brilliant piece of equipment. I've used an MFJ analyzer in the past. You know, you make an adjustment, then you use the analyzer to tune across the band, see where it's resonant. I've borrowed David VK's analyzer, which is much more digital with push buttons and a very nice display. But that type of thing, you do a sweep, you see what the resonance curve looks like, then you make an adjustment and you do another sweep. With the VNA, you see it in real time. You make a nice fine adjustment here, and you can see the curve changing, the resonance curve and the resonance frequency, all changing in real time. Wonderful device. Anyway, that's 630 meters. Oh, and as an aside, knowing the antenna current, you can sort of do some rough and ready measurements of how much power you're putting out. I know I'm putting about 200 watts into the antenna, and some rough and ready calculations will show that I'm probably radiating out of the antenna maybe 1, perhaps 2 watts. The rest of it, I guess, is heating up the ground, probably warming up the coil. It would be nice if this was Litz wound, but it's not Litz, but it is what it is. But even so, it's amazing what you can do on 630 meters. And last night I had the system whispering using the WSJT software and whisper. And when I checked the overnight records earlier today, I found that about 10 minutes before sunrise here, my whisper signal had been detected in New Zealand, which is actually very satisfying, of course. Anyway, getting back to the other sides, if I'm on 160 or 80, I have another relay just tucked in there. So for 160 meter, I just have a largest inductor. The total inductance resonates the antenna to 160 meters, and then a few turns up from the bottom, there's a tap to give you 50 ohms for the coax. So the L network on 160 is just 2 inductors. On 80 meters, the L network is a capacitance and an inductor. The capacitance is 2 vacuum capacitors in parallel, one of which is variable. The variable didn't give me quite enough capacitance that I needed, so I stuck another one in parallel with it. And then I have an inductor. And again, you can use the VNA onto this connector here. This is the cable that goes to the radio room for 160 and 80. And again, you can make the adjustments you need. I've also got a common mode choke here to try to keep RF off the feed line. Probably not that important because the feed line's buried. Okay, let's move on. Ah, yes, this is the RF ammeter. Photograph taken as the sun was kind of setting off to one side. You'll see that I'm putting almost 1.5 amps of RF current into the antenna. The meter goes back to World War II. You can see in the center the symbol of the crown, and it's surrounded by the letters AM for Air Ministry. And it was made by a company called Ferranti, which was a well-known English electrical company until they went Tango uniform about 20 or so years ago. The other interesting thing about this meter is that you can just make out the date of manufacture here, 1940, which means that this meter is actually 86 years old. I was born in 1942, so this meter is actually 2 years older than me. And it kind of pains me to say this, but I really think the meter is probably in a lot better shape than I am. But what can you do? Okay, moving on. These are the parallel dipoles for 20 and 15. One end is supported by what I refer to as the limbless tree. You can see some ropes here that allow me to pull it up and down. The other end is supported by an extension to my old TV tower, which actually has an over-the-air TV for pointing towards Bellingham. And you can't quite see it, but there are also ropes that allow me to lower this. And then there's a ballon in the middle. This was put up specifically for Asia and South America. What I'm going to now is an important point. You use these EasyNet and other programs to look at antenna patterns, but in reality is they don't reflect what the average guy has got. You're somebody like me, you've got a house on the lot, got a backyard with a lot of trees, you've got neighbors with houses with trees, you may have overhead power lines, and all of these are going to affect the radiation pattern. And what I have found is I can be in, say, some form of CW contest, and I'm using the big antenna, and I can be on 20 meters or 40 meters, and I'm working Japanese, and sometimes I work in South Americans, and I'm not even using the one that you see here. But what I will say is that when conditions get really rough, and the JAs or the South Americans, I'm having a hard time having them hear me, or they're having a hard time working me, that's when I switch to these parallel dipoles, and that's when I will notice a difference. That will often make the QSO possible that I wouldn't otherwise do. So they are useful, but if you like, secondary to the big antenna. I think I made reference before. Let me just make sure I'm in the right order here. Yes, I made reference before to high voltages on these LF antennas, and that double throw relay, which I showed you where the 450 ohm line comes in. At one time I had that in a plastic plumbing container. Then I got up one morning and realized that I wasn't putting out any power on 630 meters. The power supply seemed to be showing a dead short. Turned out that the field effect transistors in the transmitter had blown. So I went out to the backyard to look at that relay, and this is what I found. The relay I was using was actually in this white plastic plumbing enclosure. I've been experimenting with the antenna and other things, and unfortunately overnight something came a bit loose, and all of this 450 ohm line that went from here to this point here all caught fire and melted. So I cut it off there, and then I replaced it. I can see Rick is really chuckling away there. So yes, so you can see, and as I said at the bottom here, that's my contribution to the low frequency Hall of Flame. And I have read about people, and particularly in the UK, have set garden sheds on fire and wooden fences on fire and that type of thing. So you really have to be careful with some of this stuff. Okay, this is the last of the slides. I tried to put together something that shows you how I got to where I am, specifically trying to specify what I want to design it and implement it. And as I say, the internet is a great source of information, particularly EasyNet for radiation patterns, bearing in mind that when you live in the suburbs, what you see on EasyNet is not necessarily what you're going to end up with. And then you've got things such as a nano VNA and other stuff. So as I say on my very last line there, it's never been so easy. So that's it, Glenn, finished.
Fabulous. Thanks, Brian. Okay. Questions? Does anybody have a question?
Yeah, is there going to be any discussion of your antenna tuner? Is it a balance tuner to drive that balance line?
No, actually, the balance line comes into the tuner and it goes through a common mode choke, which is about 12 or 13 turns, if I remember, of number 14 house wire wrapped around an FT240 31 core, if my memory is correct. And the balance line goes into the beginning of the windings, and the other end of the windings, one end goes to ground, and the other end, what you might want to call the hot end, actually goes to an L network. And the L network consists of a variable inductor and a variable capacitor. And then there's a switch that allows me to switch the variable capacitor to one end of that variable inductor or the other end. And then with a combination of the variable inductor and the variable capacitor, I can match it on the HF bands. So that's what my matching unit is. All homemade, of course.
And of course, you can buy ATUs already made, of course, and that work with the doublet. So you have to look.
Yes, yeah,
look
you can buy
those up on the
ATUs.
internet.
Yeah, you can buy ATUs that take balance inputs.
Yeah. Any other questions, gentlemen? This has been a great presentation. Andy?
Oh, one thing I was going to add, if I may, guess nobody picked up on this. In fact, took me a while to pick up on it. My doublet is 54 feet long. If you're familiar with the G5RV antenna, that's about 104 feet long. So my doublet is actually pretty much half the length of a G5RV antenna. It's an interesting observation,
Interesting
and
point.
it's worth reading up about the G5RV, and you'll see actually, other than the fact that mine is half the size, there is a fair amount of commonality between the two of them in terms of the length of the radiating element.
Interesting.
Yeah, just an observation.
Yeah, you had your hand up. I know Rick had his hand up also, but Andy?
Well, I was just going to say, I don't have a question. I just wanted to say, watching this makes me think this is how I always envisioned amateur astronomy to be. And I guess how I thought of it as a kid, but never got there. It's so much more the real thing than just buying a radio off the shelf and using it, which is what I've been used to doing. So I really, really enjoyed that, Brian. Thanks a lot.
Oh, well, my pleasure. Yeah.
I'll swing to Kurt. Go ahead, Kurt.
Yeah, Brian, when you put the nano VNA on that doublet, do you just get just flat SWR across multiple bands, or does it rise and dip? What does that look like?
Well, I guess it depends on the span that you choose. Like on 630 meters, which goes from, well, it's about 472 to 479 kilohertz. I chose probably plus or minus 50 kilohertz either side. And because it's such a high Q antenna, you have a very, very noticeable dip. If I just went 10 or 15 kilohertz either side, then obviously it would be much shallower. So the real answer to your question is it depends on the span of the antenna you take, the span of the frequency.
It's that doublet with the ladder line feeding the dipole is what I'm thinking. You've got a fairly low Q on that, I would expect. How does that look on the VNA?
Okay, when it comes to the doublet, as I said in answer to Roger's query, when the doublet comes to the ATU, it goes through a common mode choke, and then it goes to an L network. Now, I could have put the VNA at the end of the common mode choke, but I didn't bother because I knew I was going to use an L network, and I knew, any inductance up to about 20 microhenries was probably going to be enough, and capacitance probably up to about 300 or 400 would be enough. So it was just a case of fiddling them both until the SWR was minimized. I could have put the VNA at the end of the common mode choke, but I just didn't bother. Just adjusted until I got a match.
It looks to me like your low band use of the doublet, it's actually a Marconi.
Well, I've never really sure now what's meant by a Marconi and a vertical and things like this. So
That's
I
top
don't know.
loaded vertical. Isn't that a Marconi? I don't know. I always thought it was, but
Well, I would call mine a top-loaded vertical. Now, did Marconi have top loading on his antennas? I'm not sure. He might have done. Of course, a lot of verticals
also,
don't have top loading, so would you call them Marconis?
no. No, I have a distinct vision in my mind of what a Marconi looks like. It's got a horizontal component.
Okay, well, maybe mine's a Marconi.
I'll have to look
Of
it
course,
up, but I
Marconi,
think
he didn't use balanced line joined together at the bottom, though.
no single
Yeah,
wire going up to
yeah.
a horizontal wire.
Okay, well, if that's a Marconi, I'll
I think.
accept it. Yeah.
I would like to know more about your design of the coils. Physical construction, rather.
These are the ones for what? So 160 and 80 meters?
Yeah.
When you say coils? Well, the 160 meter is a piece of this commercially made mini ductor, which I don't think has been made for, I don't know, maybe 30 years. So that's what it was. The one for 80 meters, again, that's something I had in my box of useful pieces. It's just an inductor wound on some insulating material. It's probably about 1.5 inches, if I guessed, maybe 2 inches diameter. It's got a few taps on it. And knowing the inductance and capacitance I needed, because that's when I used my VNA to measure the reactance and then calculated the inductance and capacitance. So that's kind of how I knew what I needed to make it all work.
Now, Don, I know that Brian would probably love to show you firsthand in his shack what he's doing. Unfortunately, he's going to be going to Thailand pretty soon, so that might be a problem. But that probably the best way to find out what he's doing with it.
Yeah, it would be. I'd be interested to see it. It's. I'm faced with not having anything for DX. Really, I have an inverted V on 40. Not really going to do the job, so I'm going to have to feed a very short tower, and I'm going to have to be very creative because I don't really have a lot of place to put ground wires either. So I'd like to see what you've been doing.
Yeah.
Zach, you're Zachariah. You flashed your hand there for a second. Did you have a question?
I did. So the length of your antenna is 54 feet and your height above ground is 50 to 55 feet. Is that coincidental that they're about the same, or is that intentional?
It's purely coincidental.
Okay, so it doesn't necessarily factor into the performance of the antenna.
Well, factor into the performance. I guess if I had it up a lot higher, I guess it would be better.
But it's not critical for the antenna itself and the design.
No, the height of it was not factored in. No.
Okay.
How about you, Rick? Did you have a question?
Yeah, I was kind of curious, Brian, the voltages that you're developing in that box where you let the smoke out. I've blown stuff up on 160 meters with 100 watts. Just curious, do you have any idea what sort of voltages might be in there?
Well, enough to set it on fire.
But
I did.
Those frequencies are just amazing.
Yes. I think I tried to. Yeah, I think I did actually. Looking through the low frequency. It was a book on LF stuff from the RSGB, and a lot of information there on radiation resistance and calculating radiated power, as well as equipment as well. And it was also something in there about voltages developed. Can't quite remember what it is, but as
It's
I
probably
say,
a few kilovolts, several kilovolts, I would think.
well, as I say, it was enough to set it on fire.
Yeah. And your leaving the rig is, you estimate what, 200 watts?
Yes.
Yeah, and 1 watt at the antenna is the estimate as well. That's amazing.
Well, 1 watt being radiated. So,
Radiated, yeah.
yeah. Yeah, that's because
Thank
of
you.
of an incredibly low radiation resistance, because the antenna is so short on 630 meters,
Yeah.
and a very poor ground. I'd like to have. I probably got maybe 1,000 feet of wire buried, but it all goes higgledy-piggledy, this type of thing. And as I say,
The
my wife's a great gardener, and doubtless some of those radials have been sliced through over the years.
the completely fried piece of ladder line, the 400 450 ohm ladder line, I think is quite stellar. Well done.
But as I say, my contribution to the Hall of Flame.
Any further questions, gentlemen? We've gone about close to 45 minutes now.
Yeah. Oh, the only other thing I make is it actually works very well. I'm really very pleased with it. Of course, living in the suburbs, you get a high noise level, but on 80 meters in the mornings, if the band's open to Japan, I will work several Japanese stations on 80 meters. Bands are good, and that's with an S8, S9 noise level.
That's amazing.
Yeah.
Just